coded 0 for the 713 code. So the stabilizers I want are these 6 stabilizers, and then also I want to have logical Z for the 7th stabilizer. And that'll be logical 0. Alright, so I have 3 X stabilizers, so that means I'm gonna have to start with 3 qubits in ket plus. And I'm gonna have 4 Z stabilizers. So I'm gonna start with 4 qubits in ket 0, and you'll see in a second why I did it like that. And so the idea is that I'm gonna have some sequence of C0 gates, and so these X stabilizers are gonna be copied forward into these X stabilizers, and these stabilizers are gonna be copied backwards into these stabilizers and that one. Okay, and okay, so let me just give you a circuit that does it, maybe. Okay, well, I'll do it sort of a dumb way. So this looks like a 4-qubit cat state. It is a 4-qubit cat state. So that gives us X, which is this stabilizer. Now I want to get, let's say, this stabilizer. So I do that. So this X stabilizer is sent to X, which is what we wanted. And it doesn't mess up this stabilizer at all, because X, there's no control wires here. So it still comes out as I, X. Right, so that's good. And for the first one, let's just do the same thing. Let's do 1 to 3, 1 to 5, 1 to 7. So this gives us all 3 X stabilizers, because again, these C0 gates don't mess up the earlier X stabilizer, the one from before. Okay. I guess in practice, probably what you'd want to do is like to parallelize some of these. So for example, like this gate can be applied at the same time as this gate, because they involve different qubits, or things like that. So if you wanted to, you could do this in just 3 rounds instead of 9 rounds. But whatever, so that's sort of an optimization, I guess. Right, so this gives us the X stabilizers. What about the Z stabilizers? What should we do for those?
I mean, are we, is the circuit partly also doing this? Or?
Sorry? It's doing something, right?
Yeah,
it's copying
something.
Like Z7 is being copied backward to Z1, 2, 4, 7. This is not one of these.
It's not one, yeah.
But it might be one of these, like, because it might be equivalent to one of these or something.
Oh, right.
Some linear combination.
So we just have to go through and look at what it's doing and see.
Yeah, okay, so that you could do that. So one thing you could do is you could compute the 4 Z stabilizers by propagating the Z's backwards. Like for example here, this Z3 becomes Z1, Z2, Z3. It's copied backward twice. And Z1, Z2, Z3 is just logical Z times this guy. So that's good. That's already good. And I guess that means if we put in logical 1 here, or sorry, if we put in physical 1 here, we'd end up with logical 1. Because this is just becoming the logical Z. That's good.
Seems like it should hold for the other ones maybe.
Yeah, so actually it sort of holds automatically because, I mean, why is that? It's because duality? Is that why? I mean, there's only one set of Z stabilizers that commutes with the X stabilizers. So once you get the X stabilizers right, the Z stabilizers have to be right because they're orthogonal. They commute with the X stabilizers.
I see.
So let's see. Mathematically, what I'm saying is, if you think of the X stabilizers as binary vectors, 0, 1 to the 7, the Z stabilizers are exactly the orthogonal complement of the subspace of the X stabilizers. So once you get one right, the other one comes for free. So we're done. Okay, so this prepares the state. So then the question is, how do you prepare it tolerantly? we have the same issue that we had before. So, okay, we have several issues. So let's talk about, okay, let's start with the same issue we had before. So if you have a fault here, an X fault here, it's copied into a weight 2X error, which is bad. Alright, so or a fault here is copied into a weight 2X error, or a fault here is copied into a weight 2X error. So those are all bad. Again, those are the only bad cases. Because an X error here becomes a weight 3X error, but that's equivalent to weight 1. So there are only
3.
Bad X faults, bad X errors. What's it, bad X errors? You could have, what are they? It's X1, X7, X2, X7, or X4, X7.
okay. So we need some circuit that checks all of these, and I guess what can we do actually?
I'm in 7.
What? Yeah, so they all have 7, so that's good. Right. So I mean, it's. I was gonna say something like this, like just check the last 2, but that won't work actually. Because this won't work because now the code's the code is not a cat state now, so this is not. It won't preserve the. If there's no faults, this is not gonna work. Yeah. So what do I do?